Hello everybody. I'm pleased to present to you the FloodML project, which deals with flood monitoring with machine learning. The main idea here is to develop machine learning algorithm applied to satellite data to automatically detect flooded areas. It's to say, from ingested satellite data, apply those FloodML algorithms we developed using a training database we created, and then use those algorithms to automatically detect water areas, as we can observe here on the right side. So which kind of satellite data we use? We use Sentinel-1 and Sentinel-2 data because they are free, because they present a 5-year data set, because they offer both VV and VH polarization for Sentinel-1, for instance, and 13 spectral bands for Sentinel-2. And what we have to keep in mind is that the classic methodologies for water extraction from those data are using thresholds, backscattering coefficient thresholding, for instance, for SAW data, and thresholds applied to synthetic bands, as we can observe here with the MND WI in this particular case. So what we want to develop is an algorithm which can get rid of those thresholds to automatically detect those watered areas without any supervision. So for the training of our data, we used the global surface water occurrence here, which presents a probability of water presence over 30 years of Landsat data. And we only kept the occurrences of 90%, and we use those pixels, those particular areas, as training areas for our algorithms. We also needed for Sentinel-1 SAR data slopes, and to derive slopes from a DEM, we used the MERIT multi-area removed improved terrain DEM, which is very suited to hydrological purposes. And then for the training, using a random forest algorithm, we train on Sentinel-1 data or Sentinel-2 data slopes on the pixels detected from the water occurrences, and then we made the training to create the database used for the inference. To know where to learn and when to learn over flooded areas, we used the Emergency Management Service database, which provided information about places and times of flood events, and which also provides, for checking purposes, shapefiles containing the delineations validated for the EMSR. So over 27 areas of the world, we made trainings and tests. And for instance, in Lithuania, we got those results with flooded areas correctly detected here between the MSR and the FloodML inference. We have also many other detections, as we can observe here, which might be linked with very wet soil and melting snow and even frozen soils, creating perturbations on the wave at wave level. We also have an impact over frozen rivers and also frozen seas, as we can observe here. We have a very good results here in central Greece flood event, with very good results, very good agreement between both data sources, with some misdetections in some areas in mountainous areas, and we could check those inferences from SAW data with optical data, thanks to an image of the same date, despite the 10 hours time lag between both information. We also have a good agreement in this case in Spain, but with some noise due to wind over the water surfaces. We have in Iran here many other detections due to sandy areas and wave penetration in the sand, creating a very low backscattering coefficient. So we still have work to improve the inferences over sandy areas. And those are some results we can show you about FloodML presentation. So thank you for your attention, and of course contact us if you have more questions to ask.